Hello, I am Forecaster and this is Railcraft routing. First, let's have a look on the three items you're going to need. First, we have the golden ticket, which is crafted with a piece of paper and a gold nugget. Give you a golden railway ticket, and these can be stacked up to 64, and you can craft them 64 at a time. Next, we have the normal railway ticket, which is crafted with a golden railway ticket and a piece of paper, and the golden ticket is not consumed. You can craft with it as many times as you wish, and the railway tickets stack to 64 as well. And you can also use an existing railway ticket to craft a new ticket, which will of course overwrite the data on the ticket with the data from the golden railway ticket. If you have a destination set and an issuer set, the golden ticket, the railway ticket will have that information as well. And lastly, we have the routing table, which is crafted with a book and quill and a lapis lazuli. And since book and quill does not stack, you can only craft these one at a time, but these also stack up to 64. Now, to edit these, you will hold them and right click, and as you can see, you can type in a destination in your golden ticket, and there's a little help page here, and when you have written something, you click done and it will be saved. And if you edit a stack at the same time, all of them will be written with the same information, so all of them will have the same destination and the same issuer. You cannot edit railway tickets. The only way to set them is to craft them with a golden ticket, so that's their purpose, and once used they will be consumed, so they are one use, which is the entire point of them. While the golden railway ticket will never be used up by anything, you will always be able to get it back. And the routing table is a little more complicated. As you can see, it has a lot of space. You can turn the pages similarly to a book and quill. There's a manual with help, all the operators, all the keywords and how they work, and an example with a few combinations and an explanation of the example. Now, the same applies to these. You can, if you write something, so if you write Dest moon and then done, you'll see that all of these will say Dest moon. And if we were to change one of these, you'll notice that we can stack these two that still say moon, but they will not stack with the one that says Mars now. And the same goes for tickets. They can stack as long as they have the exact same data, but once they are different, they will no longer stack. And that's the crafting and some basic editing. The golden tickets and the routing tables can be re-edited as many times as you want. There is no limit and no way to finalize them. The routing tables can be named. You can give them a title similar to a book and quill, and it will add that title to the item name, but it is not finalized. You can still edit it, and you can change the title, and you can change the contents still how many times you like. Now let's have a look at the blocks. First, we have the routing detector, which is crafted with 8 chiseled quartz block blocks and a pressure plate. And this is one of the 2 blocks that accept routing tables. The second is the routing switch motor, which is crafted with a routing detector and a switch motor. And this has a similar interface, also accepts only routing tables. And finally, we have the routing track, which is crafted with a golden ticket, as you can see, and a few other standard components. And when you craft it, you can also use a regular ticket, but when you craft it with a golden ticket, the ticket is not used up. If you use a regular ticket, the ticket will be used up. And this needs to be right-clicked with a crowbar to open up its interface, and this accepts tickets. Only golden tickets can go in this. You cannot insert a standard ticket, because what this does is simply setting the destination of a locomotive that passes over it to the destination of the ticket. So it needs a ticket that can be reused. And I'll demonstrate this later. Now let's get to some routing. Here we have a locomotive detector with the primary color set to light gray and the secondary color set to gray. And here we have a default locomotive with the primary color light gray and the secondary color gray, just like they come when you craft them. And we have a regular switch motor and a Y-track. If we set this on its way, it will be triggering the detector, which will activate the switch, switching the Y-track from the default path, which you can see is this way, to the this path where the locomotive now is. And it's being noisy. So this is a way to route locomotives without the new routing system. Here we have 2 routing tables with a color condition, with the primary set to light gray and the secondary set to gray. We will put one in the routing motor and the routing detector. And here we have a locomotive. Wait for it to heat up. And this is the same colors as this one. And it's heating up. There we go. And now you'll see that it is routed onto this path, and there is currently a bug, it seems, with Y-tracks that make them not update when switched. You can also see the routing detector is triggering. If we remove these and send it again, it will go down the default path, which is, as you can see on the Y-track, is this way. The unswitched path, if you will. Now, let's have a look at some of the conditions that are available. Here we have a colored locomotive, a brand new routing table, and a brand new golden ticket. We put down the locomotive here, we can see that the primary color is blue and the secondary color is green. If we take the routing table and we type color, and then primary is blue and secondary is green, and we put it in the detector, you can see it triggers because there's now a matching locomotive next to the detector. If we put in the wildcard any, it will also trigger, because there is now a locomotive with the primary color blue and any secondary color next to the detector. If we put in red as the secondary color, the detector will not trigger because the secondary color is not red. If we check the manual, we can see that we have 3 operators available. The AND operator, which checks if both the following conditions are true. We have the OR operator, which checks if either of the conditions are true. And the NOT operator, which inverts the following condition. And by default, you can imagine that there is an OR here. So we could, for example, add another color, and we can say blue and green. So now we have color locomotives that are either blue and red or blue and green. So if we put this in here, you'll see it triggers. And if we remove this, and we get a blue and a red, and we find ourselves a new locomotive, and we also put down a crafting table here, and we set the secondary color to red, so we have a blue-red locomotive. You can see that the detector also triggers, and it triggers on both of these. Whoops. Let's go steal a piece of track here. But if we were to put down a gray locomotive, the detector will not trigger. The NOT operator requires one condition to follow it, which it will invert. But the AND and the OR operators requires 2 conditions following them. So we can type AND here, and we put it in here, and we will get an error, insufficient operands and this is because the AND operator only has one condition after it. So if we were to add color blue green and put it back in here, we get no errors, but the detector is no longer triggering on this locomotive, despite us having the blue-red in here. And it will not trigger on the green locomotive either, because the AND operator combines these two and means that both of them have to be true at the same time for the total to come out as true, which causes the detector to output its redstone signal. And since we're using the same condition here, we want the locomotive to be both red and green at the same time, which is impossible. So this right here is not very useful. We can put an OR here instead, which means the same as if there were no operator, that it has to be red or green, which would cause it to trigger on either one of them. But if we want to use the AND operator, we will have to use a different condition, such as the owner and the owner is the one who placed the locomotive, which is me. So now if we put the routing table in here and put down the red locomotive, we get nothing. Oh, I threw away the wrong one. Let's do this. Owner, forecaster, and then we put one in here, and you can see it triggers because the locomotive is blue and red, and I placed it. Whereas if we place the green locomotive, this I placed, I own it, but it is not red, so it only matches one of these, and so this is true, but this is false, and this needs both to be true, so this outputs false. So the total is false, which means that the detector cannot output a redstone signal. Now, you can make pretty complex condition trees using these, and what you cannot do is something like this. If we were to add a color here and say blue and red, sorry, we use that one, green, and now we have a block here which is both of these needs to be true, but since we have an OR up here by default, which means that this needs to be true or this. So if we were to put this in here, we'll see that it triggers, and if we put this down, it triggers as well. Now, if this were a multiplayer server and someone else put a blue-red locomotive here, it would not trigger, because this AND requires the blue-red locomotive to be owned by me. If someone else placed it, this would evaluate to false, which means this AND would evaluate to false. So if the locomotive is red, it matches this. It does not match this. So this would all be false, which means the detector would not trigger. Now, we can add a useful little condition here called redstone, and it's a Boolean. It can be true and false. And what it does is detect if the detector is receiving a redstone signal, like so. So here we have a lever with a redstone wire leading into the detector, and we have the redstone equals true. But if we were to pull this lever, nothing would happen. And this is because the detector only checks the routing table when there is a locomotive next to it. So now, if we pull the lever, the detector has a locomotive, so it's checking the conditions in the routing table, which currently only reads redstone signal equals true, and there is a redstone signal, so it outputs its own redstone signal. If we turn off the redstone signal, the output stops, or if we remove the locomotive, and it can be any locomotive because there are no other conditions. Now we can grab this back and we can do and color equals blue, red. So now, if we put down the green locomotive and turn on the redstone signal, we get nothing because there's a blue-green locomotive here and not a blue-red locomotive. If you put down the blue-red locomotive here, we get nothing until we turn on the redstone signal and put in the routing table. And with the green we get nothing. And when the redstone signal is off, it matches the color. This equals true, but there is no redstone signal, so this is false. So the AND output's false, and we get no output. Now, if we wanted to make it accept both a green and red locomotive at the same time, we cannot just add a color blue-green here, because it will not include this in the AND. So if we were to put one of these in here, turn on, we would get the same result as before. But if we put the green locomotive here, it does not need the redstone signal, because this evaluates to true and outputs true, and this outputs false. But since this isn't included, the total is true, which means we get an output. What we can do is add a new AND, but we have to grab this first. And then have another redstone equals true. So now we have two blocks, this AND and this and we have the default OR here. So this or this needs to be true. So we need to have a blue-red locomotive and a redstone signal, or a blue-green locomotive and a redstone signal. So now we have a green locomotive and a redstone signal equals output, or a red locomotive and a redstone signal equals output. The next condition we are going to look at is the needs refuel condition. And this says if the locomotive is low on fuel or water, this will divert it, which means it will equal true or false, depending on which you set it to. So if we type needs refuel equals true and throw one of these in here and then put down a locomotive, we see we get an output because this locomotive has no fuel. Now what it checks for is if it has water, and it needs to have at least half a tank of water. So if we throw the sticks in here and then we fill it with water, and on the third click we have half a tank of water, and it stopped outputting because it has plenty of sticks and more than a half a tank of water. If we were to go one below 1 millibucket below half a tank, this would turn on again. Now, if we remove one stick, we get an output because now it has too little fuel. So this is how many fuel items it needs to have for it to have enough fuel. Although the most important is the water, because this is what runs out the quickest. So that's that condition. It's quite simple. And the next last condition is the name. And it says true if it matches the minecart's name. And you'd think it would be this name, steam locomotive or minecart, but it's not. Here we have a regular minecart that I have named Pi in an inventory. So if we type name equals Pi, and remember that it's case sensitive, and put this down here, we'll get an output because this minecart is named Pi. If we have another minecart that is not called Pi, we do not get an output because this is named, this doesn't have a name, nor does this. And you cannot type minecart in here and it will not match Pi or the unnamed minecart. Now it's time to do some actual routing. Here we have 3 locomotives with one set to Pi strawberry destination. We'll turn this on. This is set to Pi blueberry destination, and this doesn't have a destination at all. And we have a total of 3 routing switches. This one has a routing table that says Dest equals Pi and then /. And this one has Dest equals Pi / strawberry, which matches one of the locomotives. And this has the same except blueberry. Now, if we turn this locomotive on, it will go. And since it does not match the destination set in this routing switch, it goes straight ahead and goes along the default path. And if we turn these on, we will see that this and this matches the Pi / that these have, because when a routing table checks a destination, it starts from the beginning and then checks this part against this destination, and the whole thing doesn't have to match. These have different destinations, but since they both start with Pi, they both match this switch. But this have an additional part, so this one does not match this string, but this one does. So this is sent down this path, and this is sent down this path. So you could have a main path and then have a a subpath, and then that path can have several subpaths, and so on, for as much as you can fit in a destination string. Now, the / is not required. You could have an asterisk, a dot, or nothing. The string matching works however the string looks like, as long as part of it matches. Now, here we have a locomotive with no destination set, and we have a routing table which says not destination equals pi. So this means that if we put this routing table in the switch motor, that when a locomotive comes down this way and its destination is not pi, it will output true, which means that the switch will toggle the track. And if it matches pi, if the destination is pi, it will output false, which means the switch motor will do nothing and the train would go this way. So we have the opposite of this, where the main path takes off in this direction and the destination offshoot is in here. So if we let this run, you'll see that this did not have a destination, so it continues along the default path, while any train that was going to pi would go down there. Here we have the routing track, and we have a golden ticket and a crowbar, and the golden ticket is set to pi. So if we take this and put it in the routing track with our crowbar, we have a locomotive here with no destination. Now, if we let this run as soon as it is warmed up, there we go. It passed over the routing track, still has no destination because the routing track is not powered. If we powered it and send the locomotive back, you can see that as soon as it passed above the routing track, its destination is now pi, and the issuer is forecaster. So all the information from the ticket got passed onto the locomotive. Now, another way of setting the destination of a locomotive is through item loaders. If you load a ticket into a locomotive, it will be automatically put into this slot right here. Now, the locomotive track is probably a better way to do that, but you need a golden ticket. To use regular tickets to set the destination one time, you have to use a loader. And it is important that you set the mode to transfer and add the ticket to the filter, because this tells the loader to only load one ticket if you leave it on the default mode and do not put anything in the filter. It will dump the entire stack of tickets into the locomotive, where one will be consumed, and if you have more than a stack, it will put one extra in, so you have a stack of tickets here with one in the buffer set as the destination, while in transfer mode you've told it to only move one ticket at a time, so when the locomotive passes by, it will move one ticket over to the locomotive, which will be consumed and set the destination. And of course you could use a golden ticket here as well, but if you did that, it would put the golden ticket into the locomotive and it would be left there and follow the locomotive. And you cannot extract tickets from the locomotive with an unloader. So if we send this on its way, it got one ticket, set the destination. There's now one missing from the buffer. An important thing to note is that you have to the data in the filter item has to match the tickets here. So if you were to put in tickets here with a different destination without changing the filter, it would not load the new tickets because they do not match. Now here we have a new locomotive and we have two destinations, pie and cake, and we have also two routing tracks with two tickets in them. This one is set to cake, so at pie the locomotive passes and its destination is reset to cake, and at the cake destination the destination is set to pie. So any locomotive that is routed into pie will have its destination changed to cake, while other locomotives that use this line would just pass by without any interference. So we need this ticket over here, which is set to cake. So we stop this and put this in here. Its destination is set, and we can remove the ticket. It'll keep its destination. It will now be routed into cake, and its destination is now pie. It'll be routed into pie, and it'll then go back to cake. And it will keep going back and forth without having any complicated machinery that tells this locomotive apart from other locomotives. So other locomotives can pass by here without being led into these destinations, while this one can go back and forth using the same track as others. Here we have a very simple three-way intersection. We have a locomotive with its destination set to red, where it currently resides, and it needs water. And we have three routing switches. This one obviously has the destination blue, and this means that if a locomotive comes here and its destination is blue, it will be switched over to this, or it will go this way, while if it has no destination or any other destination than blue, it'll go down this way. So this white is the default, be it the home base or grand station or something else. Here we have a destination red, so any locomotive like this one here matching red would be led onto this path and end up over here, while if it is not red, it would go down this way and it would end up at blue. So if we tell this locomotive to go, it does not match blue, does not go down that way, and here it matches red and is led up this path. Now if we take a golden ticket and we type blue, and when we wait until it comes by, does this, its destination is now blue, so it will be led down this path and end up at blue because it came from red and it matched this switch destination, so it went down that way. And it did not match this switch as red, so it was not sent up this way. And here it did not match this switch as red either, so it was not sent up this way, but went to blue instead. Of course, you could fork this, so you had a default path continuing and another intersection here that said that blue was to be sent up this way, and any other train would continue along. Here we have an example of using two operators at once. We have the not operator inverting this OR. So we have two destinations, pie and cake. So we have destination equals pie or cake, but we have a not here, which effectively says destination not equal pie or cake. So if we put this in here, we have three locomotives here. This one has destination set to pie. This one has destination set to cake. And this one has destination set to space. So as soon as these heat up, we will send them on their way. So this one has pie, so it is sent on its way. It does not match the condition. So we had pie, the destination was pie, and we wanted not pie, so the switch did not trigger. Here we have cake, and we want not cake or not pie, and here we have space, and space is not pie and not cake, so this was diverted. Now lastly, we have a little example setup where we have multiple switches. This one sitting on the main path has these conditions: needs refuel equals true, and we have OR and redstone equals false, and destination equals resupply. So the locomotive needs to either be refueled, or the redstone signal has to be false and the destination has to be resupply. So we have the incoming redstone signal here. Then we have this switch, which has the AND redstone signal equals false and destination equals resupply. So here we have a little refueling station with a water tank and a liquid loader, and an advanced item loader told to load charcoal into locomotives. We have a chest, and we have the refill station for the refueling station. Over here, we have a locomotive, which is, of course, out of water. And it has the destination set to resupply. So when it comes along here, it will match the destination equals resupply. But for this AND to return true, the redstone signal needs to be off, which it currently is, because over here we have a comparator which checks the contents of this chest. So we have charcoal in here, and as you can see by this redstone display, the output signal is currently 2. So over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 steps until this repeater. So when the output of this comparator is 9, this will strengthen the signal, which will go to all of these 3 switches, and the redstone signal will be true. So when there is enough charcoal in this chest, these 3 switches will be this. The redstone signal will be true, which will make this condition return false, which will, since both of these needs to be true, if one of them is false, this will return false, which means that if locomotive matches this condition, it will be routed into this path. And the same with this. This means that if the destination is resupply, but the redstone signal is on, the locomotive will not be routed into the resupply, but it means that this train must have come in here because it needs to be refueled itself. So we go into this path and receive more fuel and water. So currently we have the redstone signal is off because there is too little charcoal. We have 2 chest carts full of charcoal, and we have a little loading station here with an applied energistic system that supplies infinite charcoal to this loader, and this does not need to be reloaded at the moment. So if we follow this locomotive, it will be routed in here because its destination, the redstone signal, is off, and this is the refueling train, and it will start unloading charcoal into this chest. And as you can see, the redstone signal is steadily increasing as the chest is filled, and once it reaches 9, I believe it should be. Yes. So once it reaches 9, this will turn on, and all of these switches will be receiving a redstone signal, which means that the refueling station is enough stocked to not need to be refueled at the moment. It doesn't mean it's full. It doesn't need to be full. But since this train is here anyway, it will fill it up as much as it can. Now, if we were to do something funny here, tell this only to fill minecarts, which it can't do. And this is still filling this up. And as soon as it's full, it will send the train on its way, and it will go back onto the main track. And if we speed this up, see, it no longer diverts into the refueling depot because it does not need refueling itself, and the redstone signal is on, which means that the station is stocked. But if we were to slow this down and steal some charcoal from it and turn it back on, it now matches the needs refuel condition, so it will be diverted in here on that condition, and it will not match this because the redstone signal is on, so it'll go straight and it will be refueled, so it'll receive some charcoal and then go on its merry way. It'll be sent back out here, and it will go around. Now, this is not restocked properly. We'll stop it here. And if we were to delete all the charcoal from it, and we would delete some charcoal from over here, and this is being refilled from the unloader, which has some 9 stacks of charcoal in it. If we were to remove some charcoal here, the redstone signal is now off, and it does not have enough charcoal to turn it back on. And we'll now see a flaw in this system. If we send the locomotive on its way, the redstone signal is now off. This is still the only resupply train, so the resupply station tells the switches that it needs to be resupplied again, so the locomotive is diverted into the resupply station. But the supply train has no charcoal. So, and because of the way I've laid out the track, the supply train now loops around because this switch thinks that this train, it assumes that this train has charcoal to resupply it, while it does not. So this works as long as you make sure that your locomotive is supplied. Now that's it for this video. I've explained a few things about routing. Now behind this wall over here, I have built a pretty big demo setup where I have a few locomotives running on a 2-link track like this one. I have a few destinations. I have a resupply station like this one, but with a design that can differentiate between loaded and unloaded locomotives or supply trains. So when a train is empty, it is sent back to the main base, if you will, where it is refilled, while if it's still loaded, has some charcoal in it, it is accepted and will go in to refuel or resupply the refueling station. I'm still waiting for and completing some things in that setup, so that will be a separate video, which will hopefully come shortly. And that's all for this video, so see you later. Now let's get to some routing. Here we have a color detective